So in this class, I want us to consider working with the sign room. What is it that you're supposed to understand that is from the sign room, from the proof, and also the use of these formulas? So what you're going to need actually is the understanding of a non-right angled triangle. Remember, before you used to work with a right angled triangle where you're given a 90-degree angle. And on a right angled triangle, you were using the ratios, whether you are working with the sine, the ratio of the sine, the ratio of the cos, and also the ratio of the tan. That is what you had. You're using the ratios, the trigonometrical ratios. But when you're referring to the sign rule, you are working with a non-right angle triangle, considering that this is ABC. So we have got our triangle referred to as ABC. It follows that the angle A corresponds to the side, which is opposite, that is A. The B corresponds to the side B, which is small letter B. The C corresponds also to the side C, which is the small letter C. So in any triangle that we might be given, which is a non-right angle triangle, we can refer our sign rule as A over the sine of A. Take note, the side over the sine of the angle is equal to the B over the sine of the angle B that we are given, which is equal to C over the sine of C. So take note, these are sides on top, and the A, B, and C are the angles affected by a sine. So that is sine of angle A, sine of angle B, and sine of angle C. We can also just transpose these on top, meaning to say we can have the angles written on top. The sine of A over A being equal to the sine of B over this B, and this is equal to the sine of C over C, where we are having the angles on top, A, B, and C. We are used to this, given these formulas, and you are just using or taking the formula as it is. But the question is, how are we going to prove this? So the question is, how are we going to prove that this does exist in a non-right angle triangle? This rule exists. All right, let us consider a non-right angle triangle ABC. So in this case, I'm going to start with a consideration that we are having an acute angle triangle. So let us just have an acute angled triangle. So that is an acute angle triangle. We are referring the angles that we are having, that is being less than 90 degrees. Remember the concept of acute. Obtuse, that is greater than 90 degrees. All right. So given the angles A, B, C, like I stated before, if this is A, this is B, and this is C, it also follows that opposite to A, we have got side A, opposite to B, we've got side B, to C, we have also the side C. So if we are to construct, let's say we make a construction from A to the base, which is our base BC, to the point that we can refer as D, so that this is perpendicular at this point. Let us say it is perpendicular to BC. All right. So in this case, let us say AD, let us have our AD be equal to the height. And this is the perpendicular height. In this case, we are referring to the perpendicular height. Remember, with the perpendicular height, it meets at 90 degrees. So let us consider this H to be the height of this triangle. So you can just consider that is the perpendicular height, which is the height of what? Of triangle ABC, which is having the base of BC. All right, so that is with the base BC. So I want us to consider something. Remember, what we need is to obtain these formulas that we have stated before. If you are to consider what is happening in the triangle ABD, it is now a right-angled triangle. This other triangle also, ADC, is a right angle triangle. We have a 90-degree angle in this triangle and also a 90-degree angle in this triangle. So there are two right angle triangles. And whenever we have got the right angle triangles, we can apply or we can use our trigonometrical ratios. All right, so I want us to notice something here from the trig ratios. From the trig ratios, we can have this h being written in terms of the angle B and also the angle C. So let us try to obtain something in terms of h. All right, let us consider the first triangle, which is triangle ABD. We want to write something in terms of h. All right, so from triangle ABD, triangle AB to D, we are going to notice that from this h, we can obtain a ratio which involves or which includes the h. This is supposed to be taken in terms of the sign. Remember, we want to prove something that has got a sign. So we are not going to work with a tan or a cos in this case. As we are formulating these trigonometrical ratios, we are focusing with a sign. Remember from our SOHCAHTOA concept, the sign is opposite over the hypotenuse. So let's consider the angle B, which is having the opposite being at what? At h. This is the opposite according to this B. This is our opposite, h, right? C is the hypotenuse, and this side is the adjacent. So we see that we've got opposite and hypotenuse, which is on the side. So meaning to say, we can have the sign of B in that case. That is opposite over the hypotenuse, which is the opposite, which is h, over the hypotenuse, which is C. So remember, what we want is something in term that is of h. So let us make h the subject. We're just gonna cross multiply from this. That means 1 times h is equal to C times the sine of B. So we have formed an equation of h. That is, h is equal to C sine of B. Can we have the same thing from this other triangle that we are seeing, which is triangle ADC? In terms of the angle C that we are seeing here, h is the opposite. It is not going to change. That's the opposite. Then B is the hypotenuse, the one that faces the 90 degrees. So B is our hypotenuse from this side, and that is the adjacent side. We are focusing with opposite and hypotenuse because we need a sine, not a cos, not a tan. So that means from this triangle ADC, we are going to obtain another ratio that is involving the h, which is that the one that we want to write in terms of. All right, so let us have this. So that is going to be the sine of the angle C is equal to the opposite, which is h, over the hypotenuse, which is B. That's it. We can make h the subject. This is the same as over 1. So you're going to cross multiply 1 times h, which is h, is equal to B times the sine of C. That is B sine C. So we have formed another equation of h. H is equal to C sine B. H is equal to the B sine of C. These two, they are the same. It is the same h that we are talking about. So there's no way. We can equate these two. So equate the h. So these two, since they are equal, I'm just going to equate first h to the second one. That is C sine of B is equal to B sine of C. We are referring to the h being equal to h. This h being equal to is the same thing. All right. So in a condition, as we can see, guys, we have got either a condition where we are going to have the A on top, the B on top, or we are going to have the angles on top. It's up to you. So in this case, for us to obtain, so like I said, it's going to depend. For us to obtain the angles on top, that sine of B, the sine of C on top, we simply have to get rid of this C and get rid of this B. So we need B this side. We must divide by a B. We need C this side. We must divide by a C. So in a case like that, where you need to remove these two, just divide by both B and C, these two. You want to remove that, so just divide by that. Okay, so in this case, we are simply going to divide by this B and C, the C and B that you're given there. So divide by BC. So I want you to see something. The moment you divide by this BC, you divide by BC, you are simply canceling the C and the C. This side, the B and the B cancels. That means you are remaining with the sine of B over a B, which is equal to the sine of C over a C. Guys, look what we've just obtained. This is exactly what we are seeing in this condition. Sine B over B is equal to sine C over a C. This is what we are seeing. So if we are to use the same concept, we are going to obtain another ratio being written sine of A over A in that case. If we are to let, in this case, if you are to work with this part of C, we can take the part from C, having the height from point C to E, having that is that you're going to formulate another ratio, which was going to give you sine A over A is equal to sine B over B, using the same concept. So in this case, by having this part that we are seeing, it is simply a proof that on the other part, we are going to have the same condition. So we can just have this as similar, that is similarly, we are going to obtain the sine of A over A equal to the sine of B over B from the other condition. So with this part, we are not going to actually work it out. We're just gonna, because that is going to be the same thing if you prove that. So meaning to say, you are simply going to take this, that therefore, the sine of A, which is equal to this, the sine of A over A, which is equal to the sine of B over B. Since this sine B over B is the same here as sine C over C, it is going to be also equal to the sine of C over a C. So you can actually prove it that way. With this condition, you're actually done. And with this, it is the same thing even on the reciprocal. The reciprocal of this, the reciprocal, the reciprocal. So therefore, we are simply stating that this is the same as writing this as A over the sine of A, which is equal to B over the sine of B, which is equal to C over the sine of C, which is the reciprocal part. So in our next class, we are going to be actually talking about the applications where not like in real life, but the normal problems that we can have where the sine rule is to be used. So you are going to see that it is going to be best for you whenever you are calculating angles, you use this one. When calculating angles, it is just best that you write the angles on top. Whatever that you're calculating, let it be the one on top. I'm not saying to use this one is going to be wrong. No. It is best for you to use this when calculating angles. Also, it is best for us to use this formula, having the sides on top when calculating sides. So it is also best when calculating sides. It is going to be best for you to use or to apply the sides on top. So that's the condition that you are going to have on the sine rule. So in this case, we are working with a condition where this is being an acute angled triangle that you are referring to. Let us consider in the same condition to say we now have, or we have got an obtuse angle, and you're given that they might give you such a condition in exam, and you need to prove for an obtuse. That is for an obtuse angled triangle. So what's an obtuse angle triangle? It is the one that we are now having an angle that is more than 90 degrees. So let us just consider something of this nature, more than 90 degrees. It's going to be something of this nature. We just need this to be an obtuse angle like this. So let's say we have got something like this one. It's obtuse bigger than 90 degrees. Remember, an obtuse angle is an angle which lies in the second quadrant, if you are referring to those trigonometrical ratios concept. All right, so let's say we have got our triangle ABC, just like the previous case. This is ABC, having an obtuse angle at C. Still, just like the other part that we had, the opposite angle to A is side A. Opposite to this is going to be C, and opposite to B is B. But as you can see, we can make adjustments where we can have the perpendicular height, just like the previous case where we wrote our ratios in terms of the perpendicular height. So let's say we just make constructions from A to this base, then continue with the side B to this so that it forms a perpendicular height at a point D. We have a perpendicular height. So that is a construction that is made, which is not part of our question. This is not part of our question. It's something that we are to make as a construction. So we are going to let that, because it's not part of our diagram. So let AD be equal to the perpendicular height. That is the height of what? Of triangle ABC. This triangle, so it's going to be the height of triangle ABC, which is affected by the base BC. So that is with base BC. So with this, we can formulate the same thing, just like the previous case where we had ratios which were taken in terms of H. Why in terms of H? Because as we can see, ABD, this bigger triangle, is now a right angle triangle. And also ACD is now a right angle triangle. So we can use those trigonometrical ratios from SOHCAHTOA. Remember, we are focusing with a sine. We do not want anything to do with a cos. It's a sine that you are working with. So let's try and apply the trigonometrical ratios. So from the trig ratios, just like the previous case, we're going to have the trig ratios. Let's consider B, because according to this angle B, H is the opposite and C is the hypotenuse. So that is from triangle ABD, the bigger triangle that we are given, the ABD. We are going to see that the sine of angle B, being equal to the opposite over the hypotenuse. So that is going to be H, which is our opposite, and the hypotenuse, which is C. Remember what we want. It is to write everything in terms of H, like H in terms of whatever that you're given. So let us make H the subject. Just going to cross multiply just like the previous case. So H is equal to C, the sine of B. Just like that. Just like that. Now let us consider that we are taking this also, the right angle triangle, this one, ACD. That's also a right angle triangle there. But this is what I want you to see. Remember, we are saying this is the angle C of the normal triangle that we are given. This is our angle C. Let's say, because this C here is an obtuse angle. Remember, that's an obtuse angle that we are talking about. Let's say this angle is 120 degrees. What was going to be this angle here? It was going to be 180 degrees minus 120 degrees. Why? Angles on a straight line, they add up to 180 degrees. So you simply have to subtract that from the 180 degrees. But in this case, we do know that this angle, which is our obtuse, is the angle C. That is the angle C that we are given, this one. That is the C that we have, the angle C. Just like we are given 120, what was going to be this angle, which is the acute angle in this triangle? It was going to be 180 degrees minus C. And that is an acute angle. Remember, on a straight line, the relationship is, if this is an obtuse, this is going to be an acute angle. We cannot have both obtuse angles on a straight line. It's impossible. It's also impossible for us to have both acute angles on a straight line. There are two angles on a straight line. One is acute, another one is acute. It's impossible for that to happen. It is only an obtuse to an acute angle. Obtuse, acute. That is the relationship on a straight line. So meaning to say, by being told or by knowing that this is an obtuse, definitely this other angle is going to be an acute angle. That is an acute angle. So as you are working with that, you must understand that from your trigonometrical ratios, remember what you read from the cast diagram. In the first quadrant, where we work with all acute angles, they are positive. So as you are going to determine the ratio, because we need the ratio there of this angle, which is in the right angle to triangle ACD. All right. So that is in triangle ACD. In triangle ACD, we are going to see that the ratio of the angle there, that is 180 degrees, sine 180 degrees minus C is equal to what? The opposite over the hypotenuse. In that case, the hypotenuse is B. One opposite to the what? To the 90 degrees. So that is opposite, which is H, over the hypotenuse, which is B. But remember what I was saying about the sine 180 degrees minus C. This here, we're not supposed to be scared about this. That's an acute angle that we're talking about. And for all acute angles, they remain as positive. They're just positive. And we do understand that the sine of 180 degrees minus C is simply equal to what? Sine C. So there we are simply having a sine C. Remember also from your reduction angle concept. So if this is 180 degrees minus C, it is the same as sine C. But even that concept, the sine from both, the sine in the first and the sine in the second is positive. So for sine, do not worry about that. It's an obtuse angle, it's an acute angle. Both, they are positive. So we do understand from the reduction that was going to change to the sine of C. Sine 180 degrees minus X, you are used to that, is equal to sine X, isn't it? So that is exactly what you had from your trigonometry in your term 2, remember? So that is sine of C, and it remains as a positive, and that's H over B. So let us have H as the subject. 1 times H, that's H. B times the sine of C, that's B, the sine of C. So there we have got H written in terms of B and the sine of C. Here H in terms of C and the sine of B. But these two, they represent the same H. That is, they are equal. That is the same H that we are talking about. So these two, they are equal. Just equate them. So equate these two. That means we are going to obtain H, which is C, sine of B is equal to this H, which is B, the sine of C. Just like the previous case, you want to remove this C, you also want to remove this B. So simply divide by what? By what you want to remove. So you divide by this B and C together. So you divide by BC. That's, you want to remove everything there. So you divide by BC. So by dividing this part by BC, dividing this part by BC allows us to cancel the C and the C, the B to the B. That is, we have a ratio that we are used to, which is the sine of B over B equal to the sine of C over C. That's the sine rule. Remember, that's what we want. So that is what you're going to have in this simplification. You're going to have this in the same sense. If you were going to work on the other side, working with A, you were going to obtain that. So in the similar way, we are going to obtain, it can be proved that it can be it can be proved that the sine of A, remember that's what we do not have here, the sine of A over A will be equal to the sine of B over B, just like what we saw on the previous proof that we had of an acute angle. So with this, you simply have to equate that, therefore, this sine of A over A, which is equal to the sine of B, is also equal to the sine of C over C, since this here and this are equal, and that is exactly which is equal to this one. So therefore, we can conclude that the sine of A over A is equal to the sine of B over B, which is equal to the sine of C over C. So these are the that is the final rule that we can have, the formula that we can use, which is the same thing, having A over sine of A is equal to B over sine of B is equal to C over sine of C. Like I said before, it is just one and the same thing. So you are going to need these formulas in answering of the questions. So questions can be proved. You might be given a right angled, you might be given an acute angled triangle in exam. They'll draw a diagram for you. In that case, you do not have an option. They draw an obtuse angled triangle for you. You do not have option. You have to understand how to prove from an obtuse angled triangle. You might be given the condition where they draw for you the diagram is of an acute angled triangle. They want you to prove from the view of an acute angled triangle. So this is what you're going to need. So make sure that you do revise these proofs, because they are going to ask questions on the proofs also. The applications, yes, they are going to ask questions and also expect a question which is on the proof. So it can be the proof on the sine rule, the proof on the cosine rule, the proof on the area formula. So you're going to see everything about these rules in our revision. But for now, that's it. Till we meet again.